Hello everyone, my name is Anton. So, you are AI developer or somehow related to this, and you want to run your product on the edge. Actually, there are a lot of possibilities nowadays to do this. So, in this video we will check a lot of boards and I will try to describe a lot of them. And I will try to guide you through this process of choosing the best board for your AI solution. Actually, this video, it's like, I already did one guide 2 years ago. There will be a link in the description, of course. There will be a lot of links in the description on all these boards, all my previous guides, like with discussion about each one of this board. So if you will just miss something in the video, just go down there. There will be an article with all of these links and all this information like in text. So let's start. I found that there are a lack of information in the internet about all these boards. And you just can read some press release information, and each press release from each company it sounds like our board is the best board, just choose it. But of course it's not like this. Some boards are better, some boards are terrible, and all of them like not ideal. And I doing some videos about different boards, I testing them and I put such videos on my channel. But sometimes I doing such big videos, big overviews, where I trying to like go deeper in the process of choosing such boards. And actually, in my opinion, the best up-to-date process to choose such board, it's just to go through a few criteria about that can lead you to understanding what is the best board nowadays. And there are three big criteria: product criteria, engineering, and scientific criteria. So let's go through all of them and discuss criteria first, and then we will go down there and discuss some specific boards, some application, some chip design, and so on. So actually, the first criteria is product criteria. And as the product criteria, you need to decide a few pretty general things. What's the price of your board? Because, you know, if you will buy some Sophon SG 2002 based board, something like this, it will cost you $5. But, and if you will like take Jetson Orin, sadly I have only Jetson Nano here, it can cost you like up to $1,000 for your board. And there is a continuum of solutions between them. And it's the first criteria. The second, the price of developing for such board. Because, for example, developing solution for such boards, it is much more expensive than developing solution for the Jetson board. And it's crucial, like the more cheaper board, usually the more like time, power you need to spend on developing this solution. The third criteria: how you want to produce such boards. Because if you are just installing 10 of the devices, maybe you just need to take Raspberry Pi with some accelerator, and you don't want to go deeper in the production, because for Raspberry Pi you can find any like any case, any like power supply, different add-ons, and so on. But if you're building your own like specific board, and you will release thousands of devices, maybe you need to think a little bit more about production and how you will produce all this board, who will do this, how much they will cost, and so on. And when you're thinking in these criteria, of course, like Raspberry Pi is not the best board possible. And maybe like the best boards is some Qualcomm's, RockChips, and so on. And of course, when you're thinking about this, you need to think about large batches of devices, because as you probably know, it's hard to like buy thousands and tens of thousands Jetsons, but it's pretty easy to buy like thousands of RockChips. And of course, it's like pretty complex question how you will fulfill your production with such boards. Of course, nowadays the pretty popular question for a product, in which country this product will be released, because you know, like in some countries, you, for example, like Russia, you just can't buy Jetson, and you need like somehow to buy it through third country. But on the other hand, in some different countries like US, you just can't buy Huawei board, for example, and you just not allowed to build some complex solution on Huawei, for example, medical and so on. And of course, it's reasonable because no one knows what's inside such boards, for example. And there is a continuous questions between these 2 points. Like in some countries, you can certify some specific already pre-built board, and you need to go through this certification yourself. For some countries, probably you just can buy already fully certified board, and so on and so on and so on. And you just need to solve all these legal issues. And the final product question, in my opinion, it's what will be the board power consumption? What can you like do with this specific board? And it's pretty important. Like when you are running on some edge, you if it's like Raspberry, if it's Jetson, you will like take a lot of power. Like probably with Jetson Orin, it's up to 35 watts. For Raspberry Pi 5, it's maybe 25 watts. And you need to think about like what is your limit for power consumption, because of course if you're like building doorbell that is not connected to the power line and should work from like a battery for 1 year, of course you have only few microcontrollers that are available for such task. So you need to choose like which power supply you can use. The next question you need to go through is engineering, of course, and the engineering it's starting from the simplest question. What system do you want to use? Maybe it's Windows. It's pretty rare for edge boards, but I saw sometimes it happens. But like 95% it's Linux, but which one? Should it be Ubuntu? But a lot of nowadays boards, they work with some version, only with some version of Yocto Linux or with Buildroot Linux. And for each one of them, it's probably you need some unique competence in your team. You need to build your team about this competence. And if you're building, for example, for some microcontrollers with like plain C++ code or with MicroPython, it's require like some deep knowledge about how such systems are should be developed and should be built. So like and it can change what team you need to develop your product, what understanding of the system you should take. But of course, like probably the most straightforward approach is choosing device with Ubuntu Linux, but in this case you will be limited from some of the devices. The next question, is it like separate device? Do you want to use one board with AI capabilities, or for example, you just want to connect some Hailo board to your board, or maybe you want to connect some different like Coral Accelerator, like Intel Accelerator if you're pretty like if you're developing some old solution. But anyway, and you need to choose what like will be architecture of your device. Like, should it be one device or two device, or maybe it's like the same device on camera device. The next question you need like decide from engineering side. It's what CPU you want to use, because CPU, it's usually on most of these AI boards, CPU shouldn't be used for AI solution, but you need to use like CPU for video processing, for maybe some complex calculation, maybe 3D navigation, maybe some other not neural network computations. So your CPU is pretty important part of your board, and you need to think deeper about what CPU do you want to use. And of course, the final question, in my opinion, for engineering that you need to choose before you choose your board is, do you need support from from the vendor of this board? Because if you're developing like some hardware, if you're developing pretty deep neural network into some neural network, you sometimes need support from the vendor, because some neural network, they could not be exported to the device, and you need some access to vendor knowledge. And some vendors, for example, RockChip, they just didn't provide this. You just can try to find someone who is competent in this, but it's definitely not the vendor. And some like vendors like Hailo, they are super open to this, and there is a pretty big difference between how vendors will treat you and how deep they will help you and how much money you will spend for this help. So it's pretty important questions that you need to choose at the beginning. And of course, the third batch of criteria is scientific criteria. And it's super basic for AI specialist, but sometimes it's pretty complex for some engineers and some product managers. But you need to think about inference speed for your algorithms. You need to think about what algorithms will you use. Like, should you use like some GPU for your algorithms? What layers for neural network you should support, because some old boards and some new boards as well, they just didn't support some modern layers, and just few basic layers that are not enough. It's the same for modern LLM, VLM, and other neural networks that's like have some language-based model, because all these transformer operations, they are pretty often not supported by such devices. So you need to think about memory size of the device, because for a lot of neural networks, it's crucial, like how big is your memory to upload your network. And of course, you need to think about all these problems with export, quantization, int8, quantization, and so on. So all the scientific criteria, it's about inference and how you will run your neural network. Okay, we briefly go through this 3 batch of criteria, and next I will go to the most popular vendors nowadays. And of course, I should start from Jetsons. This is super old Jetson Nano. Nowadays, it's like mostly Jetson Orins. And it seems that nowadays Jetson is just Edge by default. I started working with Jetson like in 2014, I think. And since then, they have only improved. I hope it's pretty slow process, but it's like process with improvement. And today the current series is Jetson Orin, and Jetson Orin it's like Jetson Nano, Jetson Orin NX 8 GB, Jetson Orin NX 16 GB, Jetson AGX. There are a lot of AGX Jetson, I don't remember all of them. And they all are different in terms of price, speed, devices that they are used. For example, like a super important part, it's like DLA usage. But of course, everyone choosing Jetson because GPU board, and it's pretty complex to like choose what you really need for your task because you need to choose right Jetson with right balance on with of for NPU, GPU, CPU, and it's pretty important to check. I have on my channel a review for this old Jetson Nano. Probably in future I will release some like basic guide for Jetson Orin series, what you should choose, how you should like work with it. But it's like this topic can be covered like in few different videos about different parts of the Jetson. So right now I will just briefly go through the Jetson, and the advantages of Jetson, it's like it's a huge infrastructure around, it's a vast amount of information on the internet, support of modern models. I think it's the board with the best support. Like if you want to run some super modern, up-to-date visual language model, you should choose Jetson. And with all other boards, maybe except like CPU-based board, there will be thousands of problems. So this is like the basic board if you want to support like bleeding edge technologies. Of course, Jetson it's one of the fastest board nowadays, and maybe it's the best board in terms how deep you can go on low level, because you can just write your layers on TensorRT, you can write directly in CUDA, and we did a lot of tricks for such Jetson in all times, and it's basically the best board if you need to run your custom super complex algorithm, and that's all. And cons of Jetson, of course, it's the price. They are super expensive in comparison with all these modern RockChips and so on. It's availability. It's hard to like buy a lot of Jetsons. It's usually a lot of problems with supply. It's the power consumption. Like, of course, each new Jetson, Nvidia like saying that we made it more power efficient and so on, but with each new Jetson from the same series, you need like to connect more power. Of course, Jetson it's much more faster than previous generation, but it's also require much more energy than previous generation. And maybe the last but not least problem is like Jetson NPU is primarily focused on Int 8. And actually, I didn't go super deep in this topic, but all FP16 networks on Jetson DLA unit, they are super slow, so I expect maybe it's they running this as fallback, but probably I will just do another video to speak about all this DLA and stuff around. Okay, going next. x86 CPUs, Intel, AMD. When we are discussing x86, we should probably start to talk about Intel. Like, AMD is closing the gap, but Intel is a vendor that started with a lot of AI support. They released OpenVino, which is one of the best framework. Maybe like it's more user-friendly than TensorRT and Nvidia frameworks, but of course it's like not as performant for CPUs, and maybe it like doesn't have so lot of community around, like in comparison with Nvidia, of course, but it's one of the best framework for inference neural networks. And of course, nowadays Intel, they are supporting like NPU, GPU, and CPU inference. And for NPU, actually Intel was one of the first vendors. It's like Neural Compute Stick 2, and even today you can find a lot of Intel-based products, for example, like OAX, like OAK-D, OAK-1, and so on and so on. And actually all these OAX devices that are based on Intel, maybe in future they will switch on something else. It seems like the next step for them will be Qualcomm, but I'm not sure about this. And actually it's pretty interesting how Intel developing the AI. But nowadays, as you know, probably Intel is not the first vendor of hardware. There is a lot of discussions that maybe Intel will be sold in the future. But anyway, OpenVino is one of the best frameworks nowadays available. And of course, like Intel, it's waste amount of devices, like starting from N100, which you can buy from Radxa for 70 USD, and of course it's up to special modern CPU with NPU accelerator that can cost like you up almost the same $1,000 for completely working device. And of course, like the main process, availability, you can buy any amount of devices everywhere. It's good community and support, like, and since the most network you will run on CPU, of course, it will work like much better in terms of how easy to run everything. And of course, its ability to efficiently run all modern network, because you easily can run on Intel like some modern VLM models. Maybe they will not run on NPU, but anyway, you have this ability for any x86 device. And of course, like AMD is closing the gap, in my opinion, and with each new release, it's more and more easy to run your neural networks on AMD. Cons of Intel, it's like NPU and GPU are not in every device, and of course for CPU device they maybe will be not as efficient, and of course not so power efficient. The network's support is worse than Nvidia, especially when we are speaking about NPU devices, NPU inference. But of course, you can run any network on CPU. Power consumption is like worse than Jetson power consumption, but of course, if we are speaking about CPU inference, and the price probably is also not the cheapest if we are speaking about like efficient device with high amount of TOPS per device. When we are speaking about like CPU inference, of course, we need to mention that nowadays x86 it's not the only platform you can use for this. There is an ARM platform, RISC-V platform, and like of course, like speaking of ARM platform, there are a lot of Raspberry Pis on this platform, and actually it's not terrible. For Raspberry Pi, you can run some networks like YOLO V5 through NCNN inference, for instance, which will be pretty fast for a lot of tasks. It's not like terrible performance. And if you don't need like super complex algorithm, if you don't need high frame rate, maybe even some ARM device is enough, and you need to think about this. Even like RISC-V sometimes can be pretty efficient. Okay, here we are closed like the three general platforms that like you will meet in maybe 50% of cases, and will go down there for a lot of different vendors, specifically NPU AI devices, like AI devices with some NPU acceleration. And in my opinion, the best way is start from RockChips. My channel probably has the most videos about RockChips, and the most of requests and the most of view is usually about RockChips board. I don't think that RockChips is the best platform nowadays, but definitely it's one of the most efficient in terms of price. And actually, there are a lot of vendors who provide RockChips. Orange Pi, Radxa, Banana P, Nano PC, Hadas, Firefly, Mechatronics. I think I can name many others, but like in general, it's the most popular ones. And each one of them, for example, if you need some specific device like with special connectors on it, maybe it's already produced by some of these vendors. For example, like here is pretty productional boards with RK3576 from Mechatronics, which you just can install in a lot of places and it will work. Or, for example, here is like super cheap RockChip RV1106 from Luckfox, which is like super efficient, super cheap, and you can like connect it to any camera or just build camera from this device. And of course, there are like full spectrum of what you can use. And it's not only about form factor, it's about the chips inside. Because like you can choose like RockChip 3588, which is super performant and much more performant than Raspberry Pi. You can choose like some RockChip 3566, which cost like around $20, but has Ubuntu inside, has NPU accelerator inside, super efficient and super small. Or you can choose a lot of variety between them and like below them. And the advantages of RockChips, it's price, availability. You can like buy 1,000 of such devices. You can the wide support neural networks. Like 5 years ago, it was hard to run your neural networks on RockChips, but today, for example, they support a lot of neural networks, like LLM neural networks, out of the box. They have their own framework to export like Hugging Face into RockChips. And it's pretty important, in my opinion, that a lot of stuff running out of the box. Which is super important for me. FP16 is also can be run on RockChip NPU. And you don't need to think about how I will export this neural network in int8 without like a loss of accuracy. And there is a low-level access to the NPU. It's pretty rare nowadays for a lot of boards, but you can like run your mess directly through C++ on these NPU devices. And there are few open source projects around this. For example, like, I don't remember, but there is a project with Whisper on GPL3 license, which you can just look how people running their code on this device directly. And speaking of cons of RockChips, I think it's quality. Many vendors make pretty raw board system based on RockChips. For example, from one of my friends, I hear that during the first year, around 10% of boards from one major vendor of RockChips just burn and stop working. Of course, the problem that there is most of the vendors, there are Chinese vendors, and in US and may go through some certifications and maybe some restrictions as well for some specific places. Not every neural networks can be launched. Of course, like they can run LLMs, small LLMs, but there is no official support for VLMs, and I don't know when it will be. And it's pretty complex internal NPU architecture, actually. For example, for RockChips 3588 and 3576, you need like to maximize efficiency of your neural network, you need to run a lot of parallel inferences, and there is no inference server out of the box, and you need to think yourself and build this complex solution to maximize efficiency. You can check in my article, there will be link on how to do this. Okay, let's go further. Qualcomm. I don't have here board from Qualcomm. I worked with Qualcomm platform like around 3 years ago. I tried to test at Qualcomm board this year, but it was super raw maybe and doesn't work for us. But I believe in Qualcomm that it's one of the companies that provide the most. They exported a lot of neural networks. They provide good infrastructure. They can provide good support. So it's super big company, and they're moving maybe a little bit slow with this. And it's hard to communicate with them. But they solutions, probably it's one of competitors that in future will beat Nvidia monopoly on like good devices. But actually, in my opinion, Qualcomm it's the good company with good background, but maybe it's nowadays it's not as fast, not as efficient, maybe not as cheap at different possibility. But definitely, if you like will produce a lot of your boards, they will cost you less than Nvidia Jetsons. They will cost you less than a lot of different devices. They will be more powerful than a lot of different devices. And of course, they are like super good for all certification and so on. And actually, I want to write some video on my channel about Qualcomm, but I don't want to spend like $500 on the boards that I will not use for any production run. And if someone can provide me access, I will gladly like post such videos with your names on it. Okay, let's go further. VeriSillicon. It's not the real vendor of the boards, and it's not the real vendor of the chips. It's the vendor of the architecture. And actually, the company sells chip design. And many big vendors, they're using VeriSillicon design inside. For example, like NXP. Here I have a board from Debix, and I have review on it on my channel. It's, for example, like Hadas, which is built on Amlogic. It's STM32. I don't have a video about the board on my channel, but I have interview about this board on my channel. It's Synaptics, BroadCom, and there are a lot of vendors of board that are based on this VeriSillicon architecture. And actually, it's the company provides some low-level libraries, and your experience will depend on high-level libraries that vendor will provide for you. And for example, if you will like use NXP, it will be a pleasure to use them. But if you will take some rare vendor with bad support, it may be not so smooth to run your neural network. Pros of this solution. Lots of vendors, of course, with different forms factors, different boards. such boards usually are pretty cheap and pretty energy efficient. And the cons, of course, this you need to test each vendor independently. Usually all these boards, they are not super fast. It's just one camera real time, usually for most of cases. And not all neural networks are supported, no LLM, no VLM, and so on. Unfortunately, it just can be fixed only by some new releases from vendor. And nowadays there is no low-level access to NPU. Like there is one project like Mesa 3D, but it's super hard to use. It's not like Python, it's not C++, and it's super complex project. And I don't think that it's like valuable to use it. Maybe better if you need such low-level support. Probably you should choose a different vendor. Okay, let's go further. External accelerators. In this part, I will talk more about different vendors like Hailo, Sima.ai, Axelera, a little bit like about Nvidia, Google Coral, so on and so on and so on. Sorry, not Nvidia, Intel. And the most, when we are speaking about all this accelerator, you need to think about 3 points at the beginning. What volume of data should be transferred on this device? Because for such some devices, for example, like this Hailo, it's connected to Raspberry Pi 5 through one line of PCI Express. I think it's PCI Express 1 or PCI Express 2, and there was a discussion about this. But it's not very wide channel. And Hailo can work with like 4 lines, if I remember correctly. And actually, you will just drop a lot of your inference on this communication if you need like this inference be efficient. The next point, it's like correlated with this channel. It's the latency for transfer. If latency is crucial for you, it can such devices can significantly slow you down. Sometimes, like for specifically this like OAK cameras, you can run your neural networks directly on such cameras, but it's like depend on some specific architecture, and this latency you need to think about it, and for some cases such external accelerator they might hurt it. And of course, the last but not least, if the processor, your processor should be fast enough to stream enough data through like USB 3 channels, even through M2 or PCI Express channel. So you need to use pretty performant processor to open all possibilities of your board. So what are the most famous accelerators? Let's like briefly look at them. Of course, the most popular, it's maybe Hailo. It's like one of the first vendor of such accelerators. It's like M2 accelerators. Of course, at the beginning there was like Google Coral and Intel Mavidius, but they are not popular nowadays. There is no release about them. So Hailo, in my opinion, is the main vendor that even work like with Raspberry Pi officially. And the pros of Hailo, it's good support, open community, easy to buy, a lot of quantization algorithm for them. I have 2 different videos on my channel, so just check them about Hailo, and maybe there will be 3rd video on my channel pretty soon about this. Cons of the Hailo, they are more expensive. The RockChips, they need quantization. They have a lot of great algorithms for quantization, but it's better not to do quantization if it's possible. They support a lot of transformer-based models, but a few months ago, at least, they didn't support like LLM, VLM, and Whisper, for example. So they released like Hailo 10, but I think you can buy this only at the end of this year. And for Hailo 10, they marketing built around like LLM, so probably they will support or already supported this, but I didn't test it yet. And of course there is like Hailo 15. It has almost the same infrastructure around it, but it's like CPU with NPU accelerator. You can't buy like pre-built board with Hailo 15, but if you're producing a lot of devices, maybe it's a good solution, especially if you like build your prototype on like, for example, Raspberry Pi with Hailo 8. So it will be easy for you to switch on Hailo 15 without changing your algorithms a lot. So let's go to the next vendors. In my opinion, the next two important vendors for such devices is Axelera and Sima.ai. I have interviews with both of them on my channel. Like Sima.ai is more production ready device, Axelera is more new. They have a lot of different points where one is better than the second. Better read through my article, look at the interview, and if you need such device, probably you need like to discuss with all such companies your specific case. Of course, there are a lot of other external accelerators boards, like I already mentioned Coral, Intel, but you can find a lot more. I couldn't find them easily and test them. It's Neon, BrainChip, Kinara AI, and if you knew something, if you know some different boards, just drop a few lines in comments. It's also interesting for me. Ambarella, one of the mysterious board. You won't find any reviews on the internet, but at the same way it's used in many cheap super mass market device. A lot of video recorder for cars, for example, DJI cameras, a lot of drones, and at the same time it's a completely policy of security. I know a lot of teams working with it, but I haven't had the chance to run networks on Ambarella myself. In 2018, we are at Cherry Labs were deciding which device we will use, and this was one of possibilities, but it was like showstopper for us that we couldn't like checked it ourselves. Like some different vendors, they said that they may run algorithms on Ambarella and provide us results, and if we will be ready, then they will work with us deeper. So definitely it's a cheap board, definitely it should be pretty efficient board, but it's super hard to work on no open source information. And for me, it's showstopper for most of the projects. But I think that if you are producing thousands and thousands of the devices, maybe Ambarella it's one of the chip you should consider. Okay, let's go deeper. Huawei. My channel has a review of Orange Pi AI Pro with Huawei board in it. You can check my article on Medium about this, like video. Overall, this board is quite decent and open. It's fast, cheap, relatively easy export, rich documentation. But at the moment I tested this, there was no LLM support, focused on the Chinese market, and almost all documentation was in Chinese. And it was hard to buy in Europe and USA. So maybe it's a good board from big vendor, but of course all these questions, they made this board almost useless to run your project outside China. But maybe on Chinese markets, nowadays it's one of the best board because it's super big vendor with good support, with good community, and so on. Okay. here we go. Sophon, Milk 5. Yeah. This board became popular nowadays. You can saw a lot of new boards based on these processors. You can saw like SiPeed, Milk 5, C5. There was reCamera from Seed Studio with this processor. And specifically for this board, it turned out that manufacture of the final device is much more important than the code from chip vendor. For example, my experience with Milk 5 was it's turned out that manufacture here means much more than the chip vendor himself. Watch my video about Milk 5 and using the accelerator for Milk 5 is almost impossible. There is no documentation, examples didn't work as they should. But compare with MAIX-CAM board and the video from Hardware AI. The link also will be in the main articles. And it's qualitative difference in simplicity and experience. Maybe like MAIX-CAM it's not a production solution, but there are some solutions that can work with this chip pretty nice. And in my opinion, it's okay, but you need, like when you're choosing this specific vendor, you need to look at the board vendor as well, and maybe it will be much more important than this chip. And of course, when we're speaking about like this solution, it's super cheap, quite fast, and but you need like there will be no LLM support on at least on cheap version, but there is like more expensive vendors from versions from this cheap vendor. Maybe some of them will support LLM. Most vendors are Chinese companies. It may limit it like usage. Most of boards they have pretty small amount of memory on them, and it's maybe a little bit hard to switch your like neural networks from one vendor to another vendor. Okay, MediaTek. It was one of the last video on my channel, and it was not the terrible experience, but it was pretty interesting one. And yes, it's like specifically here I'm speaking about Radxa Neo 12, and it's like doesn't support all possibilities from MediaTek. They didn't provide a lot of libraries, and probably to communicate with MediaTek directly, you need to be a big company. If you are big, pretty slow, you can like spend weeks on signing NDA, you can spend a lot of weeks to have access. Maybe it will work for you. MediaTek promised me that they will open all this access in future, but at this point, it's not the best board possible. But actually, it has super fast CPU, super fast NPU. It's pretty good, like in terms of power consumption. But at this point, this like specifically board from Radxa is probably not very useful. Okay, in my opinion, we go through main vendors today, and but I will go through a few different categories. The first of all, it's like hobby boards, and on my channel I have like Groove Vision AI and Unit V2 boards. Groove and 5 Unit V2. It's a pretty interesting direction, and maybe like MAIX-CAM that I mentioned, it's also one of such hobby boards. It's pretty interesting direction because with such boards you can create some solutions when you're not very like AI specialist. They can work out of the box. You don't need to think like deeply about neural network architecture. But if you need some simple detection or classification, these boards are great. The main problem if you need something more complex, even like car plate recognition, such board will not support it. It's super hard to run such neural networks, such pipelines on them. But if you need to build some super simple solution for your class, for your project, they are nice. It's hard to look at such board from my perspective of AI scientist, but maybe they are really nice for some cases. Next, I want to mention outdated boards. And of course, it's like on my channel, I have, for example, like ESP32, MAIX-2, GAP. No, I didn't have GAP8, but even like Intel-based board, like on my videos and some other accelerators, they are a little bit outdated nowadays, especially something like this. Coral. And when you're thinking about choosing which board you need to use, it's better to avoid some boards that were released like 5 years ago, 4 years ago, because pretty often they like companies will cancel support for such boards, and it will be hard if you like plan produce such board next 10 years. It's better to choose some more modern. In my article, there will be a lot of links about this. Okay, next, like I mentioned ESP32, but there are a lot of microcontrollers. It's not the main focus on my channel. I have only 2 videos like about MAIX 7080, 800 and ESP32, but there are a lot of them nowadays. GAP9, Sentient, which is used for Arduino, for example. Analog devices, Synaptic, Scilab, Inatera, Nordic Semiconductors. The main idea about such boards, it's usually no Linux inside. They are super energy efficient, but you need to write your code on C++ or MicroPython. Usually it's pretty small amount of memory, speed is pretty slow. It's pretty complex, like in terms of which layers are supported. You usually need to run int8 quantization and so on and so on. A lot of such boards you can work with edge impulse with them, but working with edge impulse, it's a little bit like working with these hobby boards, because it's like limiting your capabilities. But of course, it's like for some cases, if you need some super simple, super cheap solution, usually it's enough. So, other boards. This video is already super long. It's better to check my articles about this. If you have any question, write them in the description or just follow me on LinkedIn or YouTube. Thank you for watching. Bye.